Hello, everyone. Thanks for coming. This is HAIbrid Design, the best of both worlds. And so how do we as creators weave this incredible technology into our work without watering down the vision or stepping on the vision of others? Now, this is a question that I have been thinking about for a while. I've been tinkering with generative AI since the public release of Deep Dream, and that was over 8 years ago. And it's been amazing to see what latent diffusion has done in the past too. It's just been like, phew. All right, so I'm going to be talking really quickly. I am covering both high-level stuff and also some nuts and bolts, practical, technical information as well. And yeah, there's like over 300 slides in this show. So as Rick said, strap in. If you do have questions, I love talking about this stuff. I will be demoing and doing just kind of like a casual hangout demo tomorrow for at least 2 hours. So you can also email me at this address. Yeah, I'm going to start off by showing some of my non-AI art and kind of explaining why this has appealed to me for so long. And it'll also kind of frame all of the AI-generated examples, which are kind of in the same vision and the same world. So through Zirngibl Studio, I've been developing out the world of Synthara, which is a far, far future sci-fi world. So this is a 3D scene with some 2D elements in it. And so again, like 3D, 2D illustration hybrid. And so what really appeals to me, well, basically, I love complexity. I love weird, strange, exotic forms. And generative AI, even before Stable Diffusion, has been really good at that. So I love taking a whole bunch of different elements and like putting them together. And those elements can be things like object designs, but that kind of thing. But I really love thinking about the relationship between lots and lots of different objects. I don't just want to make images. I want to make worlds. I want to make things that all kind of fall together, or ecosystems. And I guess I just really like systems in general. And so things like Stable Diffusion are kind of like brain candy to me, kind of thinking about how things work. And so I also like bringing in external data into my work. So this up here is like satellite data that I inhaled into my 3D software, and this is actually printed circuit board data. And even in my more traditional like fantasy art, like this is some work for Magic the Gathering, there's still this kind of thread of this like love of lots of elements coming together, and this love of intricacy. And I'm also pretty interested in the mind's eye. I have synesthesia, and I'm just I find it really fascinating the kind of overlaps between what generative AI can do and kind of the way the human brain processes visual information. So there's this kind of trifecta, or actually more than 3 reasons, that it was almost inevitable that I would like end up in this space. And I really see generative AI, which I kind of like the term synthography for, but everyone calls it AI. It's not really AI, but it's a huge amplifier. So we can see ourselves as creators. It's kind of like being a surfer, and the water, the waves are sort of like the world. It's the forces of the world. It's the forces of business. It's all your inspiration, your connections, and you want to basically surf those waves and steer to go as far as you can creatively. And now, especially since about 2 years ago, the waves have gotten a lot bigger. And this is more of what it feels like. And there's just so much stuff out there now. And it feels like, you know what, in some ways, this is amazing. We can ride these giant waves further than we ever could before, but they could drown us. And there's a whole lot of other people doing the same thing. I mean, sometimes it feels more like this. And for many folks, a lot of these changes feels more like this. So really, for me, like fear and excitement are 2 sides of the same coin. And I very much feel both right now. I really do believe that in some ways we're headed towards a kind of artistic renaissance, but it's going to be surrounded by a whole lot of art pollution as well. And this is more like near-term fears. I don't have time to go into all of them, but I do think that I don't know how much the empowerment of indie storytellers is going to counteract unemployment in standard studios. It's really hard to tell right now. But what I've been taking is more of this like neutral mad scientist kind of approach to all of this, or mad artist. And I really think that like now is a time to like there's so much new territory here to explore, where single individuals can try things that nobody else has tried before, and like that's really exciting. And so I'm kind of in the mode of just learning, and when this industry matures a lot more, I can like hit the ground running with it. And I also do believe that the machines might ultimately help us behave less like machines. So let's dive in. So strap in, here's the overview. So I'm going to start with kind of like a high level idea of what it means to approach this in a hybrid way and try to preserve your vision as much as you can when using this technology. And I think it's important to really get an idea of how the tech works. It really helps inform how to use it in a deeper way. And so I'll go into then some comparison of the different software options out there. And then, so that's kind of the what, and then the how of like, how do we weave this into the design process and to some degree production? And so kind of going through ideation, iteration, rendering, and then my favorite section, custom training. And then also covers how like 3D generation is happening right now, and how LLMs can also be used in the art process. And finally, some ethical and legal considerations. And so we'll see what we have time for. So high-level overview. So might be one of the most important graphs of the talk, which is to illustrate the fact that it is progressively harder and harder to use AI to be very specific. That was covered very well in the last talk. It's very easy to make cool images and way, way easier than it would to make those images traditionally. But as soon as you try to get something that is part of a larger whole and balances a lot of different elements, it gets to be the point where the tortoise wins the race and the traditional approach ends up being faster. And so basically, so I think companies and individuals, anybody, you can kind of see this area under the curve is like the resources that you're putting into the project. And the best way to use AI in anything is to kind of find that and is to know where that inflection point is, where it's worth putting in the human effort. And so you look at this, and I'd say that the pessimists who are talking about just how the cultural landscape and specifically the entertainment world is going to shift, they kind of think that companies are going to kind of relax their standards of what being specific means, and they're going to make worse products because they can get the best savings or, like dip in that area under the curve. Whereas the optimists are more like, well, maybe they'll just take all these resources here and they'll just make more specific projects, like more projects with more vision, let's say. And so they're just saving these resources and adding them over here. And I really think that we're going to see a lot of both and everywhere in between. One way to also look at kind of the relationship of specificity is like, not every project needs to be super specific in every aspect. So let's say we're talking about a book cover. So in this book cover, maybe it's the third in a series and it's about a very specific sword. You have to really nail that sword. And so AI, you could do 1,000 variations with AI. And if you're not using special techniques to get more specific, you're not going to get the sword you want. Whereas maybe in that series, the environment doesn't really matter that much, or maybe you can play with the color palette. So you could say almost that AI exploits the specificity gap of where, and that's where we're going to see it being used. I think a lot of traditional artists are upset about this because this gap right here is also where the artist's voice lives. If you're a commercial artist, you can put a lot of love into the color palette or the environment, and the client doesn't really, they don't really like push back on that. So that part is yours. And so, but I also think things are going to get very complicated. We're going to see more multimedia projects that are basically, they have, there's more parameters we're dealing with. And so there might still be more pockets for which to inject human vision. Another thing that's worth talking about when it comes to the hybrid approach is that there are different ways to work with AI. You can kind of start with a human base, for example, a drawing, a painting, a 3D model, and then you diffuse on top of it. And I will get more into diffusion in just a bit. But so you're kind of reskinning it. So here's an example of a quick Photoshop sketch I made of a mech, and then running it through diffusion, you're able to refine that. Now you can do the reverse as well. You can start with an AI base and then fix it or draw over it. So here's an example of taking that same output and then doing a drawing over top of that. And then you can just keep going back and forth. Now that I have that drawing, I can use that as a control net or a guide to the final composition of the thing. So you can essentially render a line drawing. And so you can just keep kind of going back and forth. And I see it almost like as like a game of tennis or like a conversation. You're kind of, that ball is the project and you're hitting it into the court and you're seeing what comes back and you're changing that, and that affects the new trajectory. And so in all of this, is the original creative vision compromised in doing this? And in a sense, and in an important sense, yes. It really is. I think it's worth acknowledging that as creators, that anytime we work with this, it is something that kind of happens to you. It doesn't come from within. And I think it's just really important to understand that there's a trade-off happening, that you can't get something for free necessarily. So let's look at this as sort of a project. Let's say this is a little indie game, or maybe just a single illustration. You can add a whole bunch of AI elements to those initial elements, and in a sense the project will be bigger, maybe more impressive, maybe it solves your problem better, but it's still not as much yours. It's still that vision is kind of diluted, and I think it's just really important to recognize that in some sense is happening. So I have often found, not for every project I do, but for some, that it is worth adding those extra elements. And that because maybe I care more about how everything is put together, and I want to make something big, and I can't get my vision out unless it's a big conglomeration of elements. And so if I'm compromising on the individual elements, that's okay with me. I just think that it's important to be aware of that. So, all right, so let's go into how stable diffusion works. We have an art machine on our hands. What makes it tick? So it works like this. Just kidding, you guys are not getting out of this. All right, so so in computer science, there's this concept that compression is intelligence. And you could see this, that stable diffusion, which is what I will be focusing on for most of the talk. It is an incredibly sophisticated data compression machine, at least the part that's the VAE, which I will get to. So this is the architecture outlined in the original Stable Diffusion paper, which was a little over 2 years ago now. So remember that original image that I showed you guys of the little mech. So let me guide you through what happened when I turned that sketch into a more refined image. So you start with something in pixel space, and then you encode it into the special space called latent space. So this right here is called a VAE. It is a critical part of a model, specifically for stable diffusion. And what this does, it stands for variational autoencoder. And essentially what it's doing is it's converting the information of this from pixel space into something called latent space, which is around, like, for the average image size, about 1/50th the size of a standard, which is crazy if you're looking at like that. It's very cool. So once it's in this space, which is notoriously hard to describe, it's like a mathematical representation. Think of it as if you have a car, the latent space version of that car is the blueprint for how to rebuild the car. So technically, that blueprint has less information, but it encodes the critical part of how to rebuild it. So once you're in this latent space, what the next part of the model is iteratively adding noise to that image. And so you have a different model, which is right here. This is kind of the guts of Stable Diffusion. And what it's doing is you're adding a bit of noise, and then you're using a system that has been trained to detect and remove noise. And typically that's done around 25 times per image for the average quality of image. So you're not adding noise to the image, you're adding it to the representation of the image. And that was the innovation that happened around 2 years ago. It freed up a ton of memory in the graphics card. It allows you to do way more things on bigger images and faster. Now, of course, when you're denoising this thing, you've got to guide it. And so the part where you're typing in the text and it's guiding that, that's a different system. It's called CLIP, and that was released by OpenAI. Again, a couple years ago. And basically, so you can condition it. It's a model that has paired text to image, and basically you can guide it. Most people use text, but I'm going to show a very cool technique where you can actually use images to condition. That's coming later in the talk. And so basically, once all of that has diffused, it is then goes through a VAE decoder and pops out in pixel space again. So that is the run through. Now, of course, there are multiple systems at play here. I do not have time to go into how those systems work, but this is a really great course. It's actually from like 2017, but still totally relevant to how image text pair training works. So sort of like CLIP. Also, if you're interested in denoising and how that works, there is a computer file video on YouTube that kind of explains that. And if you're interested in UNets, this is another video you can check out. This is a big part of the main engine of Stable Diffusion. And then finally, I really wish I could talk about GANs. I won't, but they're very cool, and they were the main way to generate images before diffusion stepped onto the stage. So, and then finally, I just want to go into the concept of latent space, which again, it's very hard to kind of try to represent it, but some people have tried, and this is one good way to do it. This is from a handwriting recognizer. And so you can see that in the latent space, the AI kind of understands, that all the 2s are here, the 8s are here, and you'll notice the 7's here and the 6 here. Now, why is everything positioned the way it is? Well, in latent space, things are positioned based on how similar they are, how similar the model thinks they are. So you'll notice that the 7's are all the way on the other side from the 6's. That's because it's almost impossible to mistake a 6 for a 7. It's just the way the digits work. Whereas 2 and 8, there's a lot of overlapping pixels there. So it makes sense that those would be close and that there might accidentally be some 2s in the 8s that the model is, not understanding right. So that's kind of a way to try to understand latent space. And this is relevant for us, I promise. This is another very cool project and company called Nomic that is taking huge data sets, and they're taking latent space, which is technically hyperdimensional, and they're using special math to crunch it down into 2 dimensions, so you can represent it on just an image. And so I went in and they had a data set of every single Stable Diffusion beta image that was prompted. And so they're actually, you can mouse over every one of these dots. It's like over 1 million images. And so I went in and I kind of mapped it. You can see how, if you zoom in, like everything is clumped in such a way that things that are related to other things are close together. And so latent space itself, I see it as like an infinite library. We are like the librarians of Babel when we're prompting it, because every single possible combination, or it's a near infinite library, I guess, it exists. And our prompt is sort of like giving it an address of where to point into latent space. And so, yeah, I hope that gives a better context to this, because this information will come back a bit. So let's actually talk about like what's available right now. What is the tool belt for a digital artist who's working in design and illustration? One thing I want to say in general about AI generation is that the skill floor is very, very low and the skill ceiling very high. I think it's kind of it's very easy to poke at it and say it takes no skill to do, and it is kind of true at the lowest levels. If you're not being specific, that is absolutely true. But the more specific you try to be, again, you need to have a lot of technical skill to get there. So we have things like Dolly, which has almost no parameters at the bottom here. Midjourney, which has some, and they keep adding some. And there's a whole bunch of front ends that there's web apps that are basically just front ends for Stable Diffusion. And they have, they'll give you some control. But really, if you want to have a lot of control, you want to work locally with one of the big, what they call web UIs. It's called a web UI, but it's local. It's kind of confusing. So Automatic 1111 is kind of the big standard for local web UIs. But the one that I'm going to advocate for and use for most of my talk is called Comfy UI. This is a node-based editor that allows where every single function you're working with is a box, and you're dragging boxes together, and you're piping data from one box to another. And it is an extremely elegant way to look at like a complex workflow. And if you've mastered Comfy UI, you're pretty much a software developer at that point. And even then, you probably still can't get as specific as an artist just like painting, depending on what the goal is. So these are kind of like the major players right now. And Midjourney they're all kind of based on the Stable Diffusion, at least architecture. It's just that what makes these guys different is like what data that they use to train the model. And there's a few others. Firefly is the big one for the royalty-free kind of generators, but there's Shutterstock and a few other ones as well. I don't really use Midjourney. It's been a long time since I've used it, but I'm a big advocate basically for Stable Diffusion if you're really serious about doing this professionally. So I already kind of went through some of these different tools. There are so many cloud services out there. I could not list them all, but these ones are kind of more professional oriented. They give a lot more fine-tuned control. I list Crea here because they have the ability to stream your Photoshop window and do real-time diffusion based on that. And I will get into that later, but it's very neat. And if you want to get into the local scene, this one I haven't mentioned yet is like the slimmed down, most minimalist version of doing local diffusion. So that out of the way, let's talk about Comfy UI. So this is that thing I talked about with the different boxes that you're piping through data, and this is where it becomes relevant to what I was talking about with how Stable Diffusion works. So you're loading your checkpoint. That's basically your model. It's a giant file. It's usually multiple gigabytes. And then this thing called the case sampler, that's what's going on in here. And the conditioning, all the conditioning is basically your prompts. So you're bringing them in. So data basically flows from left to right. The clip here, that part of the model is this part here. And the VAE, that's what's going on here. And so there's a bazillion options. There's custom VAEs you can add. It gets pretty deep, pretty fast. And then this right here is called the empty latent image. That's basically what's here. So when you're generating purely from just a text, it's putting in a just empty latent image. It's just pure noise. Now, if you're generating to change an image, you're going to add some noise to that image, but you're still giving it an image to start with. So yeah, you can just kind of keep growing these workflows. They can get gigantic. This one actually isn't that complicated, but I don't want you to be too intimidated by it because it is a very intuitive interface, I think, especially for artists, if you can get over the initial learning curve. all of that stuff, tech stuff out of the way, let's actually talk about how to weave this into the design process. So we're going to start with ideation, like what was mentioned earlier about having your own personal Pinterest. Totally, that is a very good application for this kind of a thing. You can generate it's very good for generating novel forms, like that type of ideas. And back to like kind of the possibility space, it's like, you know, your initial ideas or your initial inspiration are like these green dots. And so if you draw an envelope around those, it's not going to be as big as if you added a bunch of these red AI dots. And then maybe your final ideas are these yellow dots that are something kind of in between all of that. And so it might look something like that. So, you know, it's important to be aware, though, that just as much as this you can expand the perimeter, you don't want to have the AI become a fence and feel constrained by it, where you're looking at it and you think that's the bounds of the possibility space. It should be a supplement. So I'm going to talk a bit about prompting. Specifically for ideation. Prompting is, there's a lot of prompt voodoo out there. A lot of people who say you need to make really elaborate statements for prompts. And at least for Stable Diffusion, you can totally just do word salad. I actually find that's more intuitive and a better way to work for me. You do have to pay attention to word order closer to the front of the prompt, the more it's going to be weighted. When you're working in Stable Diffusion and in the more advanced software for this, you can add weights to your prompts as well. I think you can do that in some of the other generators too. And then negative prompting is very, very useful. And really like throw in disparate elements. So back to that idea of latent space, you want to be combining things that you think are in the far distant corners of latent space. And that's where you get some of the most interesting results. Because generative AI is very, very good at combining two very different things. So if I were to prompt medical equipment broccoli as an example, like you're going to get some really interesting stuff. I'm also going to advocate for sort of brute force prompting, which we get to in just a bit. So here's like that idea again, like, you know, try like mix 7s with 6s, see what happens. So what do I mean by brute force prompting? So this is the web app that Zirngibl released about a year and a half ago. And the whole concept of this is that rather than making prompts and trying those out, make a prompt recipe and make hundreds of variations on those prompts, and then batch prompt Stable Diffusion with all those variations. So it's a little bit like, if you see this kind of like mining, this is sort of like the prospecting phase, you know? And so, you know, the way that this worked is that each one of these has a whole bunch of subwords within it. It's sort of like a variable. It's a container with a bunch of words, and you can randomize or permutate through all those words, whereas these are constants. So you can build up a prompt recipe and then spit out a whole bunch of variations on that concept. So you can see you can add weights with it. So I've got like weights going on, and you know, different species of crabs. You know, like there's a lot you can do with it. But that's what has enabled the ability to make thousands and thousands of images, like this one that's in the gallery show. Another really great way to kind of approach this again in more of a controlled way is called the XY plot. So the XY plot allows you here to set two different parameters, one for the x-axis and one for the y-axis. And you can basically see what happens if you change specific parameters. So this is an example of a prompt substitution, XY. So I had an initial prompt, and I substituted in the word bismuth and circuitry and things like ancient Egyptian. And then up here, these are different seeds. So these are, what a seed is, it is something that encodes a specific noise pattern. So it allows you to basically keep the same composition and the same composition of all these images and just change the one word. And so it really allows you to better understand like how prompting works on a deeper level. And it's kind of scientific. And so it's a very useful way to go about things. Another thing I want to say about ideation is that newer is not better, in my opinion. I think a lot of the mainstream models have gotten worse when it comes to creativity and when it comes to like good design bones. I think they've optimized for they've optimized for detail and realism, and it's kind of like polishing a turd, in my opinion. So this was like a very early. This is from the beta of DALL-E, and I still think that these hold up, even though they're rough. As ideas, they really work. And let's do an A/B comparison here with Midjourney. So this is Midjourney version 4, and I think all of these are very strong ideas for spaces. And let's look at what 1 year later 5 looks like. Now, you can't say these look bad exactly, but compare this top left one. Look at how interesting that is. Like, there's a lot of cool world ideas, and like you can think about how does the culture work that they would make a building like this. This is the same prompt. It's like, okay, it's boring. Like, this is just they're putting a lot of stuff at it, but it's not, there's less there. So I really think it's important to think about, like, don't just try to use the latest and greatest, at least if you're doing ideation. And another thing to think with ideation is that it is kind of limited in the sense that, like, it's really, I personally think it's very important to work in the sketchbook, and especially if you're thinking about concepts, like the relationships between things that where you're thinking in metaphor. And it's really, what this is really good at, again, is like novel forms, but it's not really so good at ideas, ideas with a capital I. I think you guys know the difference. And so, like, I'm thinking about, the Design Council's double diamond, if you guys are familiar with that and the design process. I think that generative AI for ideation is particularly good for this third stage. So their whole thing is that there's a cycle of both divergent thinking and convergent thinking. And this discover and define part is very much about, defining what problem are you actually trying to solve and thinking about it in a very human-based way, like human-centered way. And so yeah, that's just some things to think about for ideation. So let's get into iteration, which is really just ideation, but like on a smaller scale, on like a subscale. So ideation is kind of finding the overall direction, scoping the possibility space. It's blue sky. Once you've chosen a direction, you want to make variations on those. And again, I think that generative AI is very good at exploring that possibility space and making variations. It's sort of like, again, it's sort of like taking a essay problem and turning it into multiple choice. And the final result might be something that's an amalgamation of all those things. And really, like, there's this again, this back and forth process between instantiation and inspiration. So back to that idea of it compromising the vision to use, it's like, well, yes, but at the same time, like, the process is part of the vision. And so, it's I could speak a long time on that, but there's not enough time. Oh yeah, I'll just put a slide about it instead. So here's an example of doing variations. So here's some cars for the Chroma Circuit racing game. And so what you can do is just take, I drew all of these on the iPad and took one of these, and you can do like subtle variations by guiding it with different prompts. Again, using that, I'm basically adding noise to it and then denoising and guiding that denoising process. And so it's just a really good way to kind of get your mind going. And so, for example, this ladybug car, I could prompt with an actual ladybug or a military vehicle from the future, and you can just kind of push it and pull it in like different directions. Another powerful thing is something called in-painting, which is you're cutting a hole in the image, you're putting noise in that hole, and then you're guiding that denoising process just in that hole. So this might be the original image, and I want to change the materials of its torso here. So what this looks like in Comfy UI is I first running this image through something that it's hard to see, but it's a line drawing, which is kind of constraining the overall proportions of this. Then I'm cutting a hole into it. And I'm running that into the K sampler, this is denoising it. And so it's just working on that whole. So it keeps everything else pretty much the same. There are ways to do this in Photoshop. Adobe Firefly has generative fill. It also has a very useful remove tool, which I think works kind of like generative fill. Alpaca ML has a plugin. I'm not sure if it's still in development, but for Photoshop that uses Stable Diffusion to bring it just directly in there. So you can make a selection and diffuse on that. And so also, what makes image even more powerful is, and I will get to fine tuning or training, but is to train your own models and basically use those to fine tune something. So I've got this data set of these bead mechs from the world of Synthara. And I've got this rougher drawing, and I want to refine the drawing, but I want to guide it in the style of those types of bead mechs. And so I'm doing that, and as I go through these, you'll see that I'm progressively adding more and more noise to them. And the more noise I add, the more they kind of deviate from the original drawing until it just kind of goes off the rails a bit. But they still keep the character of that training set. So there's a bunch of different ways to explore design variations. One of the ones I didn't mention yet, but can show, is that you can mix images together. I know Midjourney does this. You can do this in Stable Diffusion. Pretty much anything Midjourney does, you can do it better in Stable Diffusion. But here's an example of kind of blending two forms together. And so that's pretty neat. There's an interesting control net called loose control that allows you to basically just move boxes around and choose and influence the composition based on that. So you can kind of see that's pretty neat. So yeah, it's worth watching that space. Another way to explore variations in designs is kit bashing. So kit bashing is a very modular way to work. It comes from the idea of gluing pieces from model kits together to make props for film and such. And so it's like playing with Legos, but with generative AI, it's like you can make your own pieces, and you have some control over how isolatable those pieces are. So for example, and these were actually generated back in 2018, but it was still very useful for abstract type stuff. You can see here that the great thing about using generative AI to make pieces is that you just have so much control over keeping them all within the same design family, so that here they've been isolated in Photoshop, and then I can bash them together to make creatures. So these were a bunch of these psychological horror monsters from a mega game in San Diego a couple years ago. And these were all made by basically kit bashing. And you can see just how cohesive they look, because I could make as many pieces parts as I wanted to. And so what I'll often do is I'll have like a big Photoshop file with a whole bunch of these modules in it. And I can then just put those together. And like these flowers came from the same library set. And so it's like really just treating them as these like abstract little pieces, parts to work with. Very useful. All right, so now let's get into rendering. So rendering is, I define it as something where you're taking a drawing and you're turning it into a painting, or you're taking a painting and you're turning it into a different type of painting, but it's a little more production oriented. It's a little further down in the design process. So let's start with drawing the painting. So I already talked a little bit about control nets. I'm going to show another example of that, is that you can give it a line drawing here, and a control net is a kind of modification on Stable Diffusion that allows you to guide things with, so I can basically guide it with this line drawing and constrain it to that. So here's some examples of how you've got an original line drawing, and you can explore different color and lighting and rendering possibilities with that. Very, very powerful. Here's some other examples of that. And so there's also, if you want something a little more user friendly, there's something called Viscom AI, which is very much about people who have traditional art skills and augmenting and basically rendering drawings. So you can draw directly in that app, or you can give it, this is a tiny ballpoint pen drawing I gave it, and boom, you can render it. Isn't that cool? And then what I like to do is put the sketch back on top of that so that I'm just kind of very quickly able to add some color, but not losing all of that original information. So here's another example of that. So it's not perfect, but for purposes of discussion, basically meeting fodder, it's pretty useful. So you can also take 3D scenes and renderings and turn those into paintings. There's a couple ways to do that. I'm going to show a more novel way to do that here, whereas I'm doing a toon render. So it's a kind of a shader that makes a 3D scene look like a line drawing and tricks Stable Diffusion into thinking it's a line drawing, and then using the scribble code. Well, actually, yeah, this is actually Viscom, but you can do this in Stable Diffusion. So here, I'll show another example here, and it does a remarkably good job at like figuring out overlaps and depth, which is very neat. I'll show a final one here. It did get a little bit confused with this one right here, but yeah, there are ways to deal with that. So now let's talk about rendering for painting to painting, or any kind of image to painting. And I'll talk about why this is useful in at least the entertainment design process. So once again, we have image to image. So here is a quick Photoshop sketch, and I was able to just tighten that sketch without really losing any of the meaningful information by running it through Stable Diffusion. And here's an example of image to image in Automatic 1111. So if you remember me talking about that easier to use web UI, that's what that looks like. And so the thing with 3D renders is that they're not very nice to work in as a designer. If you're starting with 3D and then you try to paint over the 3D, the painting strokes stick out like a sore thumb. You know, they look different, they're blurrier, you want them to integrate well. So think of this as like a form of intelligent blur, or kind of turning your render into a painting so it's more forgiving to paint into. Now, of course, if you add too much noise and you let diffusion take the reins a little too strongly, you end up kind of compromising the composition. So I'll show another example of that. And not just with 3D renders, if you want to do what's called a photo bash, kind of like a kit bash, and you're bringing a lot of elements together. If you look at this, you can see there's like too much detail in here. And if I want to add elements, like it's going to be annoying to paint over it. But boom, now I've got this like lovely intelligent blur that kind of it has this feeling of motion, and it's a much more forgiving thing to work into. But once again, too much noise and you basically lose the integrity of the image. So there's definitely a threshold there that you just have to play with. And here's something that's like more of a final thing, where I started with a 3D render, and this was before diffusion. This was back in 2017 or 2018. I had to break that thing into tiles, little tiny tiles, because it could only handle 512 pixels at a time, and run it through. And it took like 45 minutes a tile or something, and then reassemble them all. And then this is the final image. And it's because I was dealing with trying to communicate a mental state, a mind's eye idea, and I wanted something that was softer and didn't look like that really hard-edged 3D. So there's a lot you can do with this in rendering. Okay, now I'm going to show one of the coolest aspects of rendering coming up, which is real-time diffusion. This is called LCMs. So an LCM is a latent consistency model. It's basically a very slimmed down version of the Stable Diffusion model. So rather than running it through about 20, 25 times, it's about 4 steps. And there's less concepts in the model as well. If you think of every concept as a word, you've got this giant table of weights. That table is smaller. So that's how they're able to pull it off. But you can actually get a couple frames per second of this, which means you can paint on one side and every single brushstroke gets diffused. Like, how cool is that? Like, I actually have a time lapse of this. So I'm literally, when I'm painting, I'm looking at the right while I'm painting at the left. It is so much fun. I highly recommend it. here's another version. And so it's really a different way to think about painting and drawing. So here's like a quick example showing the kind of refinements that you can get. And so this is the prompts down here. And so, that's just with a small amount of diffusion. You can put as much diffusion in as you want to kind of change it. Or here's another version. So, it's very cool. I recommend playing with them. And another thing to consider with this is when it comes to just the concept of rendering in general. Rendering usually implies you're doing something like for production. And so if you're making an illustration and you're concerned about any kind of copyright issues of the data set, there are ways to run your 3D render or whatever you're doing through models that were not trained on any copyright data at all. So Mitsuo Diffusion is a Japanese project. It's actually been out for over a year. And it's trained entirely on, I've got another slide about it later, but it's trained entirely or almost entirely on the repositories from museums. So I think it's 11 million images, and museums have put out just an enormous amount of paintings. And so if you want to make something look like a painting, you can use Mitsuo. So here's an example of a photo bash that I then ran through Mitsuo just to, again, make it more forgiving to work in. And you can see that if you bring the diffusion up too much, it gets a little strange. The model is definitely not as comprehensive as something like stable diffusion. So if you try to prompt realistic things like I was doing here, it looks a little bit weird. You compare that to stable diffusion, which definitely has a better understanding of what rocks look like. But again, if your job is to make something that's like a painting, it's a good way to go. Okay, video. There's a lot happening with video. I only have an hour and a half. I really want to show more stuff about what's happening with video. Suffice it to say that all of what I've been talking about here also can be applied to video. So just add an extra fourth dimension to that and we're good. So here's where I've now prompted that same original video clip with bismuth, which is like what the shirt I'm wearing. It's kind of more blocky. And so, yeah, so that's what working with video looks like in Comfy UI. That's right, Comfy UI can also handle video. It's called Animate Diff. Now finally something maybe a little less exciting, but very useful is the ability to remaster images. So again, we're moved a little more into production here, but one of the things I do a lot is called progressive rendering in 3D, which makes for a pretty grainy looking image. And so I can stop that image at any time I want and then denoise it, because believe it or not, AI is pretty good at denoising things. So yeah, you can kind of see, hopefully you can kind of see the difference here on the slide. You can also do things like tighten edges for mask passes and or recover lost Photoshop files and kind of remaster them, which I had to do with this very old Riot piece. All right, finally, we're on to my favorite section, which is training stable diffusion. So I mentioned a couple times earlier about the idea of making your own data set and training stable diffusion on your work. It is worth noting that the more accurate term for this is called fine-tuning, because you're doing things to manipulate the base model of stable diffusion. You're not training the whole model from scratch. Right now, that is still a little too resource intensive, but I can get things that look a whole lot like the world of Synthara by training it on things like my 3D work, my drawings, and even synthetic data. So there are three main techniques for fine-tuning. I've got this fourth one down here, which is fake training. We're going to ignore that until later, although it's one of the coolest things you can do with this. But the first one is called textual inversion. That's the one that's almost, you could call it the least invasive to the base model. But in my opinion, it's one of the most flexible. And so most of my training has been textual inversion. One of the most popular ones in the stable diffusion community right now is called the LoRa. It stands for low rank adaptation. And I will go into that in just a bit. And then finally, there's Dream Booth. And that's where you are, that's kind of the most intensive one where you're training a whole model. So let me go into the comparison of these a little bit more here. So textual inversion is sort of like it's like teaching the model a new word. It's sort of like a new, you would give it a unique set of characters, and it's creating a new column in that giant table I mentioned earlier. And so you're not actually touching the base model itself, but it effectively has that effect where you can then prompt with that unique character and get something that looks very, very similar. Back to that library of Babel. It's sort of like almost anything exists somewhere if you can get the coordinate precise enough in that massive near infinite library. And so the next one is the LoRa. LoRa's offer a great balance between ease of training. They can be a little less intensive on your graphics card. And what's interesting about the LoRa is that it's injecting layers into the diffusion model itself. So it's not changing the layers that are already there, but it's adding new ones in there. Finally, we have Dream Booth. And Dream Booth is when you're actually changing the weights of the model itself. I find that Dream Booth is a little bit clunky to work with. I'd rather just do a LoRa or a textual inversion. The main UI for doing training, at least locally, is called Koya SS, although it can also be run in the cloud as well. And there are cloud services that allow for training. I think this one is like 70 cents an hour for a pretty good GPU. You can actually get cheaper than that, but it's a little harder to set up. Now finally, IP adapter. So IP adapter is that fake training I talked about. It stands for image prompt adapter. And what that is remember when I was talking about conditioning? It was the right side of that stable diffusion diagram. You can condition with images. You don't just have to condition with text, and that's what IP adapter is it's allowing you to run images into the model and condition with those, which effectively acts like training. They kind of it was called an instant LoRa for a while, because you can kind of bypass the whole fine-tuning process in that case and get similar results. So I'll show some examples of that. So I'm going to run you through like the training of textual inversion on this piece here. And so I broke this piece into a whole bunch of tiles. And you can, different zooms. And each tile has a caption, and there's actually an auto captioner software out there that helps you in doing this. Now, I kind of over captions these in terms of the actual content. It's a little counterintuitive, but the more descriptive you are, the less the model learns that part of the description. It learns the part you're not describing. And so the model basically learns the overall light and the detail and the vibe of the image. So it really latched onto this radial symmetry, because I didn't use radial symmetry to describe the images. So it's like, okay, that special word must be what radial symmetry is. And so here's some examples of what it's able to spit out from that. And you can get as many of these as you want. It's kind of crazy. Now, what's really neat about this is that this is like I call it like a hyperfilter. It's something that you can apply to new images, and they will inherit the character of that. So here's a starting image, and here's what happens when I apply that thing I just trained. You can see that the more noise I add and the more I let that model have an effect, the more everything gets rounder and warmer and a little more like that original vibe. So yeah, we're painting with vibes, guys. I'll show another example here of, it's a Bauhaus theme park set. And so, or Bauhaus water park, those. Who hasn't been to one of those? And so here's what I'm giving to the model. And here's just with teaching it a new word. I haven't actually changed the model at all. I've taught it a new word of what it thinks that word means. So it's not exactly like it, it's adding lines, but with the right captioning, I could probably get rid of that outline by just captioning better. But that shows like how powerful fine-tuning is. And so here's where it gets really interesting. You can combine them. So because I'm just teaching it a new word, I'm prompting that word, and I can even add weights to that. And so I can combine these, and you've combined them in different proportions. So this pure Bauhaus one plus this one that was based on one of my earlier pieces equals that. Can you see the heritability there? How cool is that? Like, you know, I just think that's amazing. Here's another one for example. And sometimes there's some quirks here, like this one came out all warm, for example, when I combine these two. That's kind of where being the scientist part comes in, is you just have to try stuff and ask, like, why did it work this way? And so I have kind of a library of vibes here of different combinations of embeddings. So I can just copy this text string and put it into my prompts when I went to influence that. So there's kind of a pipeline for creating lots of images, because I'm not just trying to create images, I'm creating training images, especially for when we're able to train from scratch. I want to make kind of my own synthetic data set for that. And so, you know, I was using that Zirn prompt tool I mentioned earlier to make broad variations on a theme. I would find an image I like, I would extract the prompt from that image and make smaller variations of that image. And that's the training set. Then you describe all of them. You run it through textual inversion or LoRa, or however you want to custom fine tune. And then you can just keep doing that. When you know, the output of that can become a new training set. And so this is an engine that can just keep running. And one thing I also want to note about this whole thing is, once again, newer is not better. And the Stable Diffusion 1.5 model, which came out about 2 years ago, I think is actually better at capturing form language and more useful things to designers than the newer models. I'm going to show an example that was trained on 1.5, because the last ones were from 2.1. So here's some pen drawings that I had made, and look how well 1.5 was able to capture the overall essence of that form language. I mean, these all look like something that could have come out of my sketchbook, and I really don't know how I would have prompted to get those. I've tried, and so it's really exciting. At least it's very exciting if you're interested in building a world where you want to have lots and lots of elements that all look like they're from the same kind of thing. And so yeah, finally, you can constrain these custom trained things using control nets. If you guys remember from earlier, control net is something you can constrain something to a depth map, to a line drawing. You can copy the composition. You can constrain something to a pose. So I'm going to show an example of what I call a bad LoRa, and how I was able to basically shape it into place. So this was an original, this was a 3D render. This is a non-AI piece, one of my older works. Again, broke it into tiles. Trained a LoRa of it, but I kind of overtrained it. So this is part of what, when people talk about overfitting, you know, the model is, I wanted it to learn the stair-steppy aspects and the colors, but it also kind of overlearned the composition. But if I give it a line drawing and I tell it to just follow that line drawing, or follow it somewhat, I think I had it follow it by around like 70%, you can kind of whip it into shape and get it to not overfit anymore. But it still has the character and the shape language that I wanted. So here's another example of using that same model. So you can see it still has that information of the stair-steppy look and all of that. And finally, I wanted to show another example of IP adapter in action. Again, that's the image prompting, so not strictly training, but basically I gave it this image. This is the composition, and so it's following that composition. But these 4 images here are part of the conditioning. This is actually what's going into the K sampler, or specifically into CLIP, which is the image to text pair. Well, it's going into the model, basically. Yeah, it's not going into CLIP, it's going into the model. So you can see that I can even add weights to them. So I can say, I want you to pay more attention to the style of this than the style of this. But you can see how it's taking all of these into account and spitting out this. And so if you look into this, both the colors and the shapes and the patterns, you can see it's kind of inheriting from these. And I was able to just bypass the fine-tuning process. And so the implications of this is that if anybody wants to rip off your style, they don't even have to custom train a model. They can just use your images very easily, in the image conditioning and do that. So it's yeah, that's something to know. So I'm just going to show some of my favorite images from, I call it more of like a style palette, and I'll go through these pretty quickly in interest of time here. But these are all, again, these are like combinations of different embeddings that capture essences and kind of the form language of that world. So, and by the way, guys, like I'm very into world building and worlds, so that's why you're seeing all these examples. All of this applies to characters. All of this applies to anything you'd want to do. This is just my lens and for working with this stuff. So, yeah, it's a lot. So speaking of it being a lot, I really recommend upping your digital asset management game if you get into this, because you're going to be dealing with tens of thousands of images, and it's very easy to get overwhelmed, to lose images, because you're like these groups of images. This is almost more like your palette. And so I use something called Photo Mechanic, and it allows you to bulk tag images. You can rate them. That's what these different colors are. So I can filter based on like what my favorites are. And it does take some time to do, but I think that if you really want to do this, especially as a professional, you really need to have a handle on your image corpus. So here's some digital asset management software I recommend. So yeah, Bridge comes with Photoshop. XNView MP is free. I like Photo Mechanic for its performance. It is not free, but it's been worth it to me. And I was actually a special test case for Nomic for their image mapping. So the only other image atlas. This is called an atlas, besides the Stable Diffusion one I showed earlier. And but I really think that this is going to be the future of asset management, where you're going to be able to have an AI that can analyze your thousands of images and cluster them based on how similar they are. And there are already some software that's doing this. So you can give it an image and say, give me the 10 most similar images to this. And then, if you're making a training set, and that's a very useful thing to have, or if you're just looking for inspiration for anything, that's useful. So basically, you can hover over these different dots, and each dot is an image, and they're clustered based on how similar the AI thinks, specifically CLIP thinks that they are. And so again, this is like a meta palette of sorts. So yeah. All right, 3D. So we've been in pixel space for this time. So let's talk a little bit about what's happening with 3D. So I don't know if you guys know this, but you can give it a single image, and you can use generative AI to not only guess the other sides of that image, but make a reconstruction of the 3D based on that. And then you can even animate it. It's a little bit janky, but that's still pretty exciting, especially if you're prototyping something like a video game. This is the 3D is not ready for production yet. Here's some. This is from, but it's basically it's pretty good for it's certainly better than gray boxes. Let's just put it that way. So. In fact, as of not that long ago, we now have pretty decent text-to-image generators as well. So this is from Meshi AI. And so, yeah, the prompts up here, it gives you a bunch of variations. You choose which one you want to add the texture to, and boom, you can export game-ready assets. Yeah, it's pretty cool. There's a bunch of options out there right now. I haven't used all of them, but I can say that Meshi works quite well and is very fast. CSM is the one that I used to make those 4 turnarounds. There's also ways to do it locally, although I don't recommend doing it unless you have a very beefy graphics card and a lot of patience. So this is one easy local one that works, pretty well, but only for one angle. So it's limited use. One of the things that if you want to do a skybox, specifically, this is called an equirectangular map. It's when you're projecting inside of a large sphere, and that sphere is basically your sky. So it's this distorted projection. And so skybox kind of specializes in the ability to generate these types of images. So you can kind of see the distortion here as you get close to the poles. And what's pretty neat about these is you can even also generate things like depth maps from that. And so that's useful if you want to add effects or add additional depth to the image. I'm also really excited about the ability to texture 3D models using generative AI. So here is a workflow that I made to texture. You guys will see what this thing is because it's kind of a famous mesh if you're in 3D. But I used these different images from the giant Synthora style palette. I ran them through IP adapter, which is what's going on. That's what all these purple boxes are. That's basically taking the colors and some of the vibe from these images. I'm prompting it here. Here's the positive prompt and the negative prompt. And here's where the special magic is once again, I'm tricking Stable Diffusion into thinking something is a line drawing and telling it to render it. I'm giving it the UV map. The UV map is acting as a constraint for the model to follow, so it can follow the flow of the geometry. And this works well if you want abstract textures. And so you can see how it's the map itself, the geometry itself on this map is kind of distorted, but it's able to follow that distortion so that then when you map it back onto the 3D shape, which is the famous teapot, it actually looks, it's kind of fixed. And I just think that this is a really cool way. Again, I don't know if I'd use this in final production, but for prototyping, it's very cool. So you can even take like a racetrack, and again, it's following the flow of the geometry, or this prototype level here. This is an arena level prototype. And you can even just use it for meshes that have like an opacity map to them. So they've got holes in them. And of course, there are some more user-friendly forms of texture generation. So this is from Polycam. And now I'm going to feature a super cool new project that has not been released to the public yet. I've gotten to be an early tester for it. It's called HAIbrid. And what this is it allows you to make a sketch of a top-down map of an ecosystem, and it will create a terrain from that and then pipe that directly into a game engine. Right now they have it working with Unreal. They've got it almost working with Unity, and it's going to be working with a couple of the others like Godot. And they're even working on ways to take an image that's like just a rendering, like a piece of concept art or a photograph, and figure out what this map is based on that photograph. It doesn't even have to be a top-down photograph. And where the AI of this kind of comes in is that it can look at, if it looks at a piece of water, so it knows, I'll show an example. So here's one that I made. So I gave it this, and it knows that a long piece of blue is a river, whereas a small piece of river blue here is a stagnant pond, and it treats that differently. And what's interesting about it is it's not using diffusion. It's actually using something that's more like an LLM to do that. And it's giving instructions to a procedural 3D modeler and that's the AI part. So it's a really interesting way of looking at this. And they're using all data that they own or that they're allowed to use. There's no like copyrighted data in the data set. So this is kind of a glimpse into the future of like what can be done with the game development. All right, so let's talk about automation. I mentioned LLMs. LLMs can actually be a lot more useful to artists than it might seem like on the surface. So let's leave the world of pixels and vertices and go to text. So most professional software, certainly in the 3D world, have a scripting language. And you can give it the scripting language to basically have it generate the things in the software. And so I've been using scripting languages before before LLMs came out, but they are very, very useful for this because most scripts are pretty simple. And so you're contending with the fact that the model has a memory limit. And so, but for simple scripting, it's very useful. So this particular script took this asset here, which is made of a whole bunch of different planes with an opacity map, and is able to remove every X of those planes. So just this little piece art operation came because of an LLM. So it's an interesting, it's kind of a multimodal way to think there. I also find that LLMs are very useful in kind of guiding you as an artist as sort of a personal tutor. So there's a piece of software that if I'm over my head in a piece of software and there's something I just don't know how to do, but it's kind of specific, I can ask an LLM to guide me through. Like pretend that you're teaching a student who's new to this software. What do I have to click? What do I have to add to do the thing? And I found that there's a new interface. It'll be out in about a month, but I've had a chance to try it, and it's incredibly useful for like learning technical software. It's called FlowSpot, and it's basically a nonlinear portal to both Claude and GPT. So you can ask it a question, it will break it down into steps, and then you can say, expand on step number 4. What do I actually have to click to do this? And it can do that. It makes a new branch here, or now expand on step number 5, and it makes a branch here. And the memory of the LLM kind of traces, there's tiny lines, it's hard to see on the slide, but they're all connected by lines. It's a little bit like Comfy UI, except it's like top down. And these can get pretty big. But through its guidance, it's also giving me Vex code in the case of Houdini. I don't know if anyone here is familiar with the Houdini 3D software, but it's all a bunch of functions you're chaining together. Again, like Comfy UI. I guess I just really like nodes. I can't stay away from them. So that is a very useful thing. So let's see how we are on time here. So I'm going to get into, so we have just left the how section, and now we're into the should section. So let's talk a little bit about ethics and legal. And oh boy, I could easily fill this hour and a half just talking about this because there's a lot here. Back when I was in school, there were always these jokes about the good art button in Photoshop. And because somehow this seems too easy. The question is using synthography in your work, is it cheating? If something feels too easy, does it mean it's cheating? And this is X cheating question has been around for quite a while, and all the way back to photography itself. And I think one of my principles of this is that it's for sure cheating if you lie and if you take something without consent. And this lying one, how I want to deal with this is just exercising transparency, is erring on the side of giving too much information about how things were made, keeping all personal records of work, and just never trying to pass something off as something that came from you when it wasn't. It's just a form of humility. And now the one about only if you take something without consent. Now this one is very gray, as you all know, when it comes to, depends on how many layers of abstraction you think that you need to ascend before something becomes fully yours. But we all have to draw that line, and sort of where I draw that line is I won't use copyrighted works for fine tuning or works that I don't own. And I'm also not going to use those as input images. So back to image, applying noise to someone else's image to make a variation unless I have their consent. And I also don't prompt off of living artists' images at all, even really when I'm just ideating. And that's just this is extremely case by case. There's no easy black and white principle you can follow you really have to go based on your understanding of how this works, your understanding of the industry, and just your own feelings about it. And back to humility, I really don't think we fully own generated works. I think that I consider them to be kind of part of the public domain. And so it's something that I'm going to communicate that about the project accordingly. I think the crux of a lot of the debate that has happened is what I call the functionalist lens versus the humanist lens. And so the functional lens basically says that like the importance of a work lies in how it impacts the viewer, regardless of how it was created. Whereas the humanist lens is the importance of a work lies in how it was created by conscious minds. And it's not too hard to guess that most software developers are functionalists, and they don't really tie. I've talked with a lot of software developers, and they don't. Most of them don't like really tie their identities to their code or the process of making code. They're all about like that final result, and wanting something that gives you the most function and the least amount of effort spent. And so it's understandable that they might look at art itself as something that it's all about just how does it impact the viewer. The humanist lens is much more shared by artists, and it's a very artist-centered way of looking at art itself. It's saying that the seat of art, the soul of art, lies in the artist's mind, and it doesn't really matter what the viewer thinks about it. And I mean, I really think that art is somewhere in between these, that art is not a noun that lives somewhere, either in the artist or the viewer. Art is a verb. It's the thing that happens when you're transmitting between the artist and the viewer. And so it's very messy. It's just sort of my approach to the is it art kind of question. One ethical aspect I've contended with as someone who's made tens of thousands of images is this concept of art pollution. And it's just this idea that AI art in and of itself might not be bad, but it might dilute the cultural noosphere so much where people just kind of get burned out on beauty, which is a very strange and kind of disturbing thought to think of. And the way I've kind of contended with that is just I've held back a lot of what I've made, or if I've shared it online, I would share it as part of some larger work, or I'd share it as part of an album, but I don't want to share it where I'm like posting a new thing every day and just kind of flooding the world with more of this content. I'm kind of like almost as a courtesy to people who work in different ways, who don't have as much raw image content to dump onto social media. I would rather share that as an album, so that album gets seen once rather than continually just kind of like hammering at people with it. Because I do really believe that we're heading for a kind of artistic renaissance, but it might be, and it will be, surrounded by an ocean of garbage. And so how are we going to find this Renaissance island? And I think there's some very interesting, talk to me later about the idea of, how algorithms could be used to help people find meaningful content among this ocean. And let's also talk about the elephant in the room or the data elephant in the room, which is like, a big aspect of the ethical concerns with this is like where the original training data came from. And my approach to this personally is I'm in mad scientist mode where my main goal is just to learn. I want to learn and use these models because right now, for personal reasons, because it helps to develop an intuition of how they work. You really have to play with them a lot. And I really believe that projects like Mitsuha Diffusion and also Common Canvas, which are models that are entirely trained on non-copyrighted work, those are, if they're trained on the architecture of Stable Diffusion, then all that learning I've been doing, I can just hit the ground running with those models when it comes to actual production. So sharing this stuff with the broader world in a bigger way, still while minding art pollution. There's a lot to think about. So yeah, I mentioned this one earlier. So you can see all the different like museums that they're training work off of, and this actually was generated in Mitsuha. And then Common Canvas. Common Canvas is sort of at the level of, they say it's Stable Diffusion 2.1. I've used it, and I think it's a little less than that, but these two images were made using the Common Canvas model and locally as well. So it's on that same engine. It's like focus on building the engine right now. There's also Adobe Firefly, which is now Adobe is not without its professional controversy, as you guys are probably aware. But at the same time, I think that especially for commercial uses, it's a really I think things will work out in such a way that it's a viable, ethical model to use. So there's also projects for individualized training. So models that where basically you can give a company all of your images. Let's say you're a small game company and you want to train a custom model from the ground up on just your work. There are ways to do that. I think it's going to become more commercially viable to just bypass, the Lion 5B data set altogether. And it'll, in just about a year, it went from 600,000 to 42,000 to train on the same model, the same data that Stable Diffusion originally trained on. And Stable Diffusion made headlines when they trained because of how cheap that was, because it used to be millions of dollars. So the cost is dramatically coming down. There's a lot of tricks and shortcuts that you can use in the training process. So that's sort of that's sort of some of my thoughts on the data. I have a lot. Talk to me tomorrow when I'm doing the demo to get more into this. But I will end with this quote, which is that if you're not arguing about terms like art and creativity, then you're not talking about art or creativity. So I also have a few thoughts on the legal aspect of this stuff as well. I have to say I'm not a lawyer, and you should not rely on this information in any manner. So basically, so a big question is who owns generated content? And I've been kind of assuming, and the last time I've done research into this, it seems like for the most part, it's considered to be part of the public domain, unless it contains content that is specifically from another IP, such as Mickey Mouse or Pikachu or something. But so the idea is that the raw outputs of AI cannot be copyrighted on their own, but if you do something to those outputs, you can copyright the part that you do. It's a little dicey, but I actually tested this. I made a game. I actually have it with me if you guys want to check it out tomorrow. It's called Visionym. It's 156 unique artifacts from Synthara, and so here are some of them. And so all of these have had human input on them. I had to make all the backgrounds white. I had to paint over them. I had to fix proportions, remove artifacts, do colored work, a whole bunch of stuff. And so I wanted to test how much are these enough edits to make this considered a copyrightable project. And I did get the copyright. It took them a while. This is the certificate. But notice something on here. It says, material excluded from this claim, all AI-generated material. So basically, they let me copyright the rule set, the graphic design of the box, and including all of the cards. But their whole thing is that, okay, you're copywriting those operations of making the background right and fixing the proportions and all those. Those fixes are yours, but the original base images are not. So it's a very complex thing. I think it's important to consider the tests or pillars for fair use in this. You have to ask yourself when you're considering is this something that's legally infringing? And so I recommend there's a lot of resources online about these tests for fair use, but yeah, definitely and like pillars, one of them could crumble and the other ones can still stand. It's a very case-by-case basis. I know it's a cop-out to say that, but that's the most accurate way to talk about it. And so, for example, is the work you're using, is that in the same industry or not? And is it encroaching on the impact one has on that industry? And I do think that like it's very interesting to look at history and the fact that it took decades for photography to be recognized as something that was a copyrightable art form after the original invention of the camera, because it was considered, the work of the machine. And basically the rule. So this is the first photograph that was considered, a work of art, because it was basically something that they said it was, yeah, that the control that the photographer Cerrone exercised over the subject matter showed that he was the author of an original work of art. So like arranging all of the stuff in the photograph, basically. So, and of course, style cannot be copyrighted in the US. And so basically, I sure hope that style doesn't get copyrighted in the US because I think it would open up a huge can of worms. I think it would benefit the very large companies over the independent artists because they'll just immediately use their vast resources to just buy up all the styles. They basically copyright all the styles, and it would become just like a nightmare of litigation, in my opinion. So as much as it hurts, I think, to have somebody's styles used, we need a better way to talk about that. And I don't think style copywriting is a good way to go. So yeah, it's a lot. In general, all of this is a lot. So to recap, we kind of went through some of the philosophy of how to integrate this into the creative vision, kind of how the technology works, and some of the nuts and bolts, and the different ways it can be inserted into the parts of design in a more granular way. And then finally, some of the should questions. And yeah, this stuff there's a lot here. It is very, very complex. I mean, on one hand, it's existentially terrifying, but it's also creatively empowering. And it's just, there's so much here. And I hope that this talk at least eliminated some unknown unknowns. I know it's kind of a whirlwind, and I went through a lot very, very quickly. But I hope it helps to better, again, scope out the space and what's possible, what's going on. And yeah, thank you again for coming. And